Alright guys, Mr. Arnold back here trying to get together Unit 3. Take a look at Unit 3, Chapter 18, Section 1, the Intro to Chemical Bonding. And before we can do that, we probably need to review a little bit about what is chemical bonding and what's going on and how that's actually working. So we're going to dip back a little bit into our Lewis dot diagrams to make sure we understand what is going on. The Lewis dot diagram shows us the number of valence electrons. And those valence electrons are the ones that we want to use when it comes to chemical bonding. So if we take a substance like sodium, sodium has a total of 11 protons, 11 electrons. Oops, there we go. All right. Well, we know we can get 2 on the first level, which leaves us with 9. We know that we can get 8 onto the next level, which leaves us with 1. So we have 1 valence electron, or a 1 dot for our Lewis dot diagram. If we take a look at chlorine, chlorine has 17 protons and 17 electrons. Again, we can get 2 on the first level, which gives us 15 left. We can get 8 on the next level, which leaves us with 7 left. Chlorine has 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 7. 7 valence electrons in its outer shell. So why do atoms bond? What's going on? What do they want to, what are they trying to achieve? Atoms are going to bond because they're going to try to become stable. And we have this magic little number, the rule of 8, or the octet rule, that says you need to have at least 8 electrons in your outer shell. Now, for hydrogen and helium and the lower ones, lithium and so on, they can actually go down to the first level, which is only 2, but everything else mostly is looking for at least 8 in its outer shell. So sodium right now has 1. It can either take 7 on, or it can try to kick 1 off. And sodium is just like high school students. They are very lazy at times, and they want to do the least amount of work possible. So sodium likes to try to get rid of its electron so that it can drop down to that lowest level, next lowest level, which it would have 8 in that outer shell. Chlorine has 7. It's looking to either pick 1 up, or it's looking to get rid of 7. And again, think about it. What is the least amount of work to do? For chlorine, the least amount of work is to go find 1 electron from a partner and take that electron from them. Now chlorine has taken sodium's extra electron. Chlorine now has a total of 8. Sodium has lost its 1 to get down to the next level, which is going to give it a total of 8 as well. So both atoms have 8 in their outer shell, which means now they are stable because we're only bonding to become stable. Atoms don't like to be unstable, so they will bond to become stable. So sodium has given away electrons, and when we give away electrons, we become positive. Chlorine has taken on electrons, and so when we take on electrons, we become negative. The attraction force between the positive and the negative is what actually bonds those 2 atoms together. So again, remember back to the last unit, sodium is positive. We called that the cation. Cats have poles, they're positive. Chlorine is negative. We call that the anion, am, not an ion, negative charge. So when we have a cation and an anion and they are close together, they will connect by donating electrons or taking on electrons. So this is a simple ionic bond. Sodium gives up its 1 electron to chlorine so that everybody can reach that magical number of 8. Now, what does that look like? Again, we're just going to redraw it real quick. Sodium, chlorine, and I use X's just to kind of show where the different electrons belong. So we have sodium giving up its 1 electron to chlorine so that they can each reach there. If I were to write the chemical formula for this, it's a simple just NaCl to represent that sodium and chlorine have bonded together. And in fact, that actual name is sodium chloride. And what you'll start noticing is as atoms bond, we drop the ending of the last name. So instead of chlorine, it is now chloride, to show that there has been a simple ionic bond that has taken place. And that ionic bond is between the positive and the negative charges from picking up or taking on electrons, or for giving up electrons. So this is sodium chloride. Sodium chloride is a simple ionic bond. It's a simple ionic bond because sodium gives its one valence electron to chlorine so that sodium can get down a level and be stable, and so that chlorine can bump up a level and be stable. Again, the magic number is 8, 8, 8. Just remember 8 when we're doing ionic and covalent bonding, and we'll talk about that here in a second. So this is simple ionic bonding. Kind of reminds you, refreshes you to kind of think about what's going on with these electrons. These electrons are what are allowing us to be able to put things together or take things apart if we talk about decomposing a bond. Sodium, again, is a metal. It is highly, highly reactive. Chlorine is a gas. It is very, very deadly. But when these two come together and when they bond, they lose all of their personal properties and they gain a new set of combined properties. Oops. So again, with what's going on here with bonding, we have electrons being given up or taken on for ionic bonding. Covalent bonding, they just share those electrons, and I'll show you how that one works in the next video. But the purpose of bonding is to get to that magical 8. And again, if we take a look over here, we started with 11 protons and 11 electrons. First level, we can have 2. Second level, we can have 8. And this left us to our third level. We had one extra one in the third level that is not stable, where the magic number is 8 to be stable. So sodium is looking to get rid of its 1 to get back here to that second level of 8. Chlorine had 2 in the first level, had 8 in the second level, and had 7 in the third level. Chlorine only needed 1 more to get up to that magical 8 number for that third level. So that's where it is willingly taking this electron from sodium and putting it in its configuration so it can now have 8. This is a simple ionic bond between a cation, which is always going to be a metal, and an anion, which is always going to be the nonmetal. And that could be a gas or a solid, it doesn't matter. Or even a liquid if we want to talk about bromine as well. So again, just kind of reviewing just a little bit about the valence electrons and actually how those all come about and are together. Hopefully that helps clarify a little bit. I'm going to have another video here, short video, talking about covalent bonding and how covalent bonding works. And then we'll talk a little bit about how we actually start to name these things. So hopefully this helps out. If not, as always, come see me.